In this video, we will learn about structure. Structure can be defined as a collection of data members that are related data members under one name. And those data members may be of similar type, may be of dissimilar type. So usually it is defined as collection of dissimilar data items under one name. That is grouping the data items. Structure is used for defining user-defined data types. Apart from the primitive data types, what we have in any programming language like C language, we have primitive data types like integer, float, double, so on. Using these primitives, we can define our own data type depending on our requirement. So this structure I am using more frequently in my course. So in this video, we will learn how to define a structure and what does it mean by the size of a structure, like how much memory it consumes, then declaring a structure, then accessing the members of a structure. Let us learn about these things one by one. Let us take an example of a rectangle. A rectangular figure will have properties like length and breadth. So it will have length and breadth. These two things together defines a rectangle. So if in your programs you need something like a rectangle, then you can define a structure for it, because rectangle is not defined by just one value, it is defined by a set of values. So that is length and breadth. So we can group them together under one name and define it as a structure. For example, rectangle. So here I define struct rectangle. Now inside this, I will take integer type length and integer type breadth. Now this is having two members that are length and breadth. I am taking them as integer type. If you want, you can take them as float or double, any type depending on your requirement. I am assuming that these are simple values which are integral type, no decimals are there. So structure rectangle is defined by its length and breadth. These two members together are defining a rectangle. So this is a definition of a structure. I have taken an example of rectangle. I'll be showing you more examples upon structures later on. So let us learn further about this one. Now, how much memory this rectangle will be consuming? See, it is having two members. This length integer type, if I assume integer takes 2 bytes, or it may take 4 bytes, but I am assuming it has 2 bytes. Now breadth also takes 2 bytes. Total, it is 4 bytes of memory. So this structure is taking 4 bytes of memory. Right now it's not consuming any memory because it is just a definition. So if I create a variable of this type, then it will be occupying that much memory. Now we have seen how to define, we have learned how to know its size. The size of a structure is the total amount of memory consumed by all its members. Now next, let us learn how to declare a variable of that type structure. So inside main function, I will write down a main function. Now inside a main function, if I declare a variable, so the method of declaration is write struct as a keyword, then give the name rectangle, then I'll give the name as R, rectangle R. This is a declaration. Now this R will occupy memory space, right? This will be created in the memory. So how it looks like R is of type rectangle, so it's having two members, that is length and breadth. So R will occupy total 4 bytes, and first 2 bytes are for length and next 2 bytes are for breadth. So yes, that is occupying memory. This is the method of declaration. Now, if suppose I want to initialize it, then I can declare and simultaneously I can initialize it. So let us say struct, I will rewrite the same thing. I will say rectangle, right? I'll use the same name, R, with values, I can say 10, 5. So length is 10 and breadth is 5. So 10 and 5 will be filled in this one. So this is how we can declare as well as initialize. This is just a declaration, right? And this is declaration plus initialization together. This is declaration plus initialization. Then inside the main memory, if you want to see where this R is created, so it is created inside the stack for the main function, is inside the stack frame of main function. So R will be having length and breadth. This is length and breadth, and this is 10 and 5. So I'm showing them side by side. So we have learned definition, declaration, and initialization. Now, how to access the members of this structure? Suppose I want to access this length. I want to modify it to 15. So for accessing the members of a structure, we should use structure variable name and a dot length. So this is length, assign 15. So this value will be changed to 15, right? So it is changed to 15 in the memory. So this is how we can access. So what is the operator used for accessing a member? Dot operator is used for accessing a member. Then r dot breadth, I can modify it. R dot breadth, assign 10. So this is modified to 10. So if you want to read or write the members of a structure, dot operator is used. Here I will calculate the area of a rectangle and show you. So directly I will print the result. Printf area of a rectangle is area of rectangle is percentile d. So here I will write the formula. So what is the formula for area? Length into breadth. So how to access that length and breadth? I have to use dot operator. So say r dot length multiplied by r dot breadth. So this is how I can access the members. So length and breadth will be multiplied, that is 15 into 10, and I'll get the result as 150. So that's it about the structure. This is sufficient, and more about the structure I will discuss when I talk about pointers and functions. So this was just the introduction to structure. So let us continue with the other topics in the next videos. So that's it. We have learned about how to define, how to declare, and how to access the members, and where it is created in the memory when you are directly creating or declaring it inside the main function, right? Declaration or initialization, where it is done. So it's inside the stack frame of that particular function. Now I will give you few more examples of structure. So I will write down few more structures to give you the idea how or where we can use structures. Let us look at the example. So the first example, I will write a complex number. So complex number in mathematics is defined in terms of a plus ib, where I is a imaginary number. So two real numbers are a and b. So where I is defined as root of -1. So if you are familiar with the complex number, then you can understand this. Otherwise, just you can Google it and find out what a complex number is. So complex number is defined in terms of a plus ib. So we need two members, a and b. So complex number is defined in terms of two elements. So that you can group them and define a structure. So here we can define it as a structure, struct complex, and inside that we can have two members. One is a, or I can call it as real part, and second one is imaginary. I can name it as b, or also I can call it as imaginary, that is img. This is the definition. Now you can define a complex number like this, and you can create the variables of complex numbers, and you can use them in your program if you need this complex number. Now next, second example, I'll take an example of a student. Suppose your program is dealing with students' information. So for a student, we can define a structure. A structure for a student may contain the details of a student. So let us say I want to store the roll number of a student, and suppose a roll number is integer type. Next, I want to store the name of a student. So name of a student is a string. So I will have an array of a type character for name. Let us reserve 25 spaces. So it can store a name up to 25 characters. Next thing, I want to store department of a student. So department is also a name. So it's a character type. Let us give the name of size 10. Like computer science or mechanical engineering or anything, you can give a short form of a department name. Next, I want to store the address of a student. So address, I can take it as of some size, let us say 50 bytes, right? So I think it is sufficient. If you want to add, you can add many things like the phone number of a student, email address of a student, date of birth of a student, a lot of things you can add. So that all together forms a single student structure. And when you declare a variable, you get all these things together. And you can access each of them individually using dot operator. So this is another idea of a structure. Now, if I calculate the amount of memory it's taking, like if I say this is 2 bytes and 2 bytes, so this is taking total 4 bytes. And if I take this one, this is integer is taking 2 bytes. So this is character type, 25 characters take 25 bytes because character takes just 1 byte. and this is 10 bytes, and this is 50 byte. So this is 60, 75, 77. So this is taking 77 bytes. So this is another example. This is just for a student. You can define it for an employee. So you can have employee ID, employee name, employee's department, employee address, employee phone number, so on. Then if you want to define a structure for a book, you can give book title, book author name, book version or edition, then year of publication. So you can have all the members. So a lot of data you can combine together under one name. And when you declare a variable of type student, suppose for example, for this, if I do further, then this is a variable I'm declaring, struct student S. So I can say S dot roll number, I can set the roll number. Let us say roll number is 10. Then I can say S dot name, and I can assign some name. Like this, I can access all the member. This is just for one student. So similarly, we can have for various students, and we can deal with their information in our program. So next, one more example for a structure I will take and show you. So next example, I'll take an example for playing cards. A playing card will have some properties. It will have a face value. Let us say kings of hearts. So this is a face value, and this will have color, that is red color, and also shape is hearts. Any playing card can be defined in terms of three properties. First is face value. Then face value can start from 1 onwards. 1 means, let us call it as ace. 1 is ace. Then 2, 3, 4, 5 up to 10. Then a J is 11, and queen is 12, and king is 13. So these are the face values from 1 to 13. The next is shapes are there. So what are the shapes? There are 4 shapes like hearts, diamonds, spade, and clover or club. So 4 shapes are there. So let us define those shapes in terms of codes. We'll give codes for them. Let us say 0 is for club. So this club will be like this, right? And 1 is for spade. So this is spade, all right? Then 3 is for diamond. Let us take it as diamond. And 4 is for hearts. So let us define these as shapes. So for each shape, I have given a number. Then now next thing is color. So as there are only 2 colors, so I will define colors also in terms of codes. Let us say 0 for black color and 1 for red color, right? So 1 for red color. So black and red color. So this is how we can define a playing card. Now this I can represent it as a structure. Let us define a structure. Struct card. What are the members? All these are integers only now. This is integer, right? So all are integer. First one is integer face value. And the second one is integer, that is shape. And the third one is integer, that is color. This is how we can define a playing card. So this is the definition. Now how much space is it taking? Suppose if I say integer is taking 2 bytes, so total 6 bytes of memory it is taking. This is just a definition of a card. Now let us declare the variable. So inside the main function, if I declare a variable of this type structure, so I can have a playing card, struct card, and just C. Now this C, how it will occupy the memory, it will have 3 members. First one is face, and the second one is shape, right? And the third one is color. Now I can access all these members by using dot operator. I can say C dot face assign ace. So for that I will write 1. C dot shape, the shape is suppose 0. So this is for club or clover. Now C dot color, this is black color definitely. So this is 0. So this is how I can create a variable of type structure, and I can initialize its member. So this will be 1, 0, 0. So you can see that I am using dot operator. Now otherwise, let us forget this. Otherwise, I can directly initialize also. Struct card C, I can directly initialize the value. That is, the first face value is 1, and the shape is 0, and the color is also 0. So this is declaration plus initialization. And inside the memory, it will be here, like C will have 3 members, 1, 0, 0. It will be inside the stack that belonging to the main function, or the stack frame belonging to the main function. Now one more thing, I'll just remove this and show you one more thing. See, inside the main function, I want to have deck of cards. So total there will be 52 cards. This is the definition of a card, so just for one card. Now likewise, I want 52 cards. So I can declare a variable struct card. Now this is the structure name. Now variable name, I will call it as deck of size 52. This will form an array of structures. This is important, array of structure. So I'll be having 52 such structures. So one structure is taking 6 bytes. Total how many bytes it will taking? It will be taking 52 into 6 bytes, right? So 312 bytes it will take. So I'll get 52 different cards. Now each card I can access it with the help of its index. Even if I can initialize this array of structures. So if I want to initialize it, for few cards I will do. First card is ace of club or clover and black color. This is first card. Then second, that is card 2, face value is 2, and this is club and color is 0. So on, I can fill this one. Now afterwards, if suppose I want to start filling the other colors, other shapes, like ace of, that is next is spade and the color is 0, right? Then card value is 2 and it is a spade, so next is color is 0. So this is face value and this is shape and this is color. So like this, I can fill up all 52 cards if I want to initialize them. So we can initialize an array of structures like this. This is the first structure, then second structure, then so on. So in this way we can initialize array of structures. If I want to access them individually, like the first card I want to display, then I can use dot operator. So let us print just a face value of first card. Printf %d deck of 0, that is this card, dot face. So it will show face of this first card. Then printf next %d and deck of 0 dot this shape. So I can display shape. That's it. I can display other things also, like colors also I can display. So this is how, by using array name, then the index, then I can access it. So here we have learned how to define a structure, how to declare an array of structure, and how to initialize. If you want to initialize, then how to access the members. So this I'll be giving a demonstration also. This is sufficient right now for the structure. More about the structure, that is pointed to a structure, and the parameter as a structure, we'll be learning them in coming videos.